Today I'm going to preface this by saying I am not a BIM guy. I have to call IT to turn my computer on and off some days. And so I'm afraid there won't be much BIM jewelry. You're going to have to make do with real pictures of real things, unfortunately. No, well, I don't know. It's up to you. Whatever takes you guys fancy, I guess. So anyway, so just quickly, I'd like to go over just a quick introduction of PCL, who we are. Talk about what is permanent modular construction, PMC. Look through some off-site solutions. Talk about the benefits and drawbacks of PMC. And then to get a little bit into why BIM is so critical to PMC and its current growth. How we use it to plan, and also how we're using it to automate our process. And then get into a little bit of how is this going to grow? How is it going to greater acceptance in the industry? And then give a little bit of my own personal opinion of where the future lies for this. So, PCL, those of you from Edmonton may know us. We're a little local company around here, actually largest general contractor in Canada, 6th largest in the US. Been around for 108 years. Geographically, we cover Canada, the US, Bahamas, and now Australia. And we operate in the buildings, civil, and industrial market. Our industrial guys have been heavily into prefabrication, modularization for well over 20 years now with their home base here in Edmonton. But we actually formed the PMC, the Permanent Modular Construction, for the business, the commercial building side of things in 2012. And with that, we are members of the Modular Buildings Institute, who I know are one of the sponsors here this week. So what is permanent modular construction? Well, here's one definition. It's prefabricated building components, parts, pieces, sub-assemblies that are assembled under controlled conditions and shipped to become part of a larger primary building project. So really, that's about breaking a project into direct elements that are going to be able to be built ahead of time, away from the final location, and in controlled conditions, and then delivered to site on a just-in-time basis. Here's another, or maybe a better definition that comes from Jura Construction of an alternative phrase, modern methods of construction, which is a construction process that can encompass the use of composite new and traditional materials and components, often with extensive factory-produced sub-assembly sections and components. This may be in combination with accelerated on-site assembly methods. So really the focus here is factory-produced sub-assembly sections and components and accelerated on-site assembly methods. So really, it's really talking to a shift from project-based construction to process-based fabrication. So when you take that definition, we can start to take a much more holistic look at our projects. We start to look at the whole project, not just discrete elements, or particularly not just trade scopes within it. It also makes us look and consider new products, or maybe existing products, but used in different applications. And that's going to open up a much wider variety of opportunities for us to look for prefabrication. For example, can we work with an individual trade and get them doing more of their own prefab? Do we need to work with a group of trades, getting them to work to pre-assemble complex or congested areas of the project off-site in a more controlled environment? Can we work with a third-party supplier who's going to supply the whole building prefabricated? I know ATCO in the room, that's one of the potential solutions, going for a full modular building. And even asking the question, can we do this, do we do it off-site? Can we do it on-site? Is there space to look at it from that perspective? So what are the kind of things it's going to make the most sense for? Well, anything on your critical path. One of the main reasons for doing off-site constructions is the ability to accelerate your schedule. So it's great that you can go and build a bathroom and install it 5 times faster by doing it off-site, but if that bathroom's not on the critical path, not going to save you any time on your schedule. So really we want to look at the items that are on the critical path as a key objective. We also want to look for the areas where there's multiple trades involved in a confined or congested area. Sometimes those are some of the most complex parts of a project, and they take 3 times as long as they need to because of how tight and confined they are. If we can get people working on that in more sensible conditions, they could be far more productive at it. Anything where you've got a lot of repetition, then you can turn it into a production line rather than an individual site-built application multiple times over. And one other one is remote locations. We look at the cost of labor in remote places, the cost of getting it there, the cost of getting the labor there, the cost of putting the labor up, even the cost of shipping materials there. Sometimes building this work offsite in a bigger center with more labor availability can be very cost competitive. So why don't we see more of this? It seems like it's a bit of an ideal solution for many challenges that the construction industry faces. Well, I think it's currently the domain at two extremes. We see a lot of prefabrication by single trades, and we had a presentation this morning from Brittany in the mechanical trades, how they're using it. And my best guess is that somewhere between 10 and 15% of any current construction project is already being prefabbed. You think about curtain wall, you think about precast, you think about pre-tied rebar, millwork. Now we're getting more mechanical prefab, more electrical prefab. So there's probably 10 to 15% that's already being done by individual trades. If you go to the far end of the extreme, doing the whole building as a modular building, that represents less than 0.5% of the overall North American construction market right now. A very small amount in total. But what that does leave 85 to 90% in the middle that could be prefabbed if we just put our mind to it. And that's a big miss for the industry. And I think the reason that's not fully being exploited yet is it requires a lot of involvement by multiple trade scopes, and that's going to create logistical and contractual challenges. It needs a greater degree of design coordination between various stakeholders, and that needs to happen far earlier in the process than in a conventional stick build. But it also relies on cooperation and collaboration, which as an industry isn't our forte yet. So why is BIM critical to PMC? Why is PMC taking off? And I think it's directly attributable to the growth of BIM over the last 10, 15 years here. Because really, BIM, the model, is the start of construction, but virtually. It's a key ingredient for us in terms of looking for what those off-site opportunities on a project could be. It allows us to break that project down and isolate potential parts and components very easily and see how they interact with other sections. In order to build off-site, we need to have accurate data and dimensions, so we know it's all going to go together. BIM gives us the ability to accurately locate and size elements and the component parts. And when we want to get that schedule advantage, we've got to be building this stuff in parallel with what's happening on site. You don't have time for site measurements. You've got to work off a set fixed dimension. We also have the greater ability to ensure when we use BIM that different trade scopes are accurately coordinated. And when you have that common shared model that everybody's working with, you come back to everybody having that same information. You're not relying on interpreting somebody else's shop drawings. It also is starting to allow to automate the process far more. And I'm going to come back to that in a minute. It can also be a very powerful planning tool for us. We use it for sequencing quite a lot. We use it within the plant. We look at it and what can we do at any one stage? How has the work progressed? And how can we tie things together? When we started down this road with the modular stuff in PCL 2 years ago, Dan Euphageles and I worked on a very simple 4D model of how our work would progress down the line. And we ran it, and as we looked at it, we realized that we were still thinking stick-built conventional sequential construction. We were looking at it now on the production line, and we could actually see opportunities where multiple things could be happening at once, where that wouldn't necessarily be possible on site. But it also allows us to use that model to plan our site work. Allows us to sequence things far more accurately. It also makes sure that we're preventing clashes and then we're not going to roll a prefabricated element down the corridor and whack every single piece of ductwork in the place. That 4D model helps us figure out our deliverers, it helps us figure out hoisting, and even the installation. But it also lets us look early at what our tolerances are. We can build to extremely tight tolerances in a manufacturing environment. It's kind of standard practice to build to very tight tolerances. But we also have to recognize that that goes out to site where the tolerances have real-life movement. So we have to look at where those are critical, where they're not critical, and how we're going to deal with those. I mentioned automating with BIM, and really PMC is the industrialization of the construction process. We can now take detailed information that's in the data that's in that model and start to tie it to production equipment. What we have here is we use a CNC equipment. We've got two pieces of CNC equipment. One of the projects I'm going to talk about in a minute, the Humber River Hospital, the bathrooms we built for that, every single piece of drywall was modeled, transferred to our CNC equipment, and then cut on the CNC equipment. The machine cut the outline of every piece. It cut any holes that we needed for light fixtures, for switches, for duct work. It also then went and marked where every single screw went, so that when our guys were installing the drywall onto the steel stud, they never missed the stud. And we also made sure we got a screw everywhere we needed one by the spec. And we also didn't put one where we didn't need one because we had telescopic studs. If we put the screw in the wrong place, guess what? The telescope doesn't work anymore. But I think there's much bigger opportunities for BIM in a production environment. I think it gives us a far greater ability to communicate with our frontline workers. For example, what if that model was taken and projected down onto the workbench, so that now you weren't doing layout. The layout was the projection down onto, told you what piece went where and how it connected. Or better still, what about a 3D hologram that came out of that model that you could really now place everything in precisely the right location? I also see it as a better opportunity for a feedback loop. It could be a two-way communication tool. What if our frontline workers could provide their input on safety, productivity, and quality right back into the model, and then we can use it as a metrics tool? What if we could connect our model up to augmented reality and use that for mock-ups? And we could really shorten and reduce the cost of those major, they're very necessary, but they're major headaches when in a construction process, because you've got to build it, you've got to review it, get the changes, go back, rebuild it, get it reviewed again, so minor to, that could be an 8, 10, 12-week process versus building it once in a model environment and walking through it and getting everybody's buy-in at that stage. I'll just go over a few off-site solutions and examples that we've run with over the last number of years here. Talk about some MEP racks, prison cells, bathrooms, and then how we start to put all of those things back together. So this was one of the P3 hospitals that we built in Hamilton, just outside Toronto, and our mechanical electrical trade decided that they were going to prefab all of the racks down the corridors in the hospital. And for those of you who've worked in hospitals before, that's a very confined corridor space with a lot of services running in it. So they were able to combine racks with ductwork, med gas, cabling, cable tray, pipe work, sprinklers, all onto one rack. They didn't take it off site. We gave them an area on their site, and they set up a 10-station production area where they just kept these things flowing. And then they'd roll them out to the site area and install them. And what we saw with that was what would typically take them 4 weeks to stick build on site, they had installed in under 4 days. They also did it far safer because we didn't have everybody climbing up ladders and doing one of these without their hard hat on, trying to get to junctions. It was all done down at ground level, far more ergonomically correct there. Proved to us that off-site really doesn't have to be off-site, it just has to be away from the final location there. One of the things that we also learned on that was you have to do a real 360-degree look around at what's going on. In this one, the mechanical electrical guys said, we're going to build the racks, we're going to go. And we said, great, go at it. And then we realized afterwards that somehow in that equation, the drywall had to go on and get in there, and that was starting to block ductwork coming off to the side. So lessons learned, making sure we understand everything around it. But from a BIM perspective, we found that we needed different levels of detail for different parts of it. Some were very, very simple runs, some were highly complex corners. This is a project out in just outside Vancouver, an example of a full volumetric solution. This was a P3 project, so it was design, build, finance, maintain. So anything that we could do to shorten the construction schedule was going to reduce the construction financing significantly. And this was kind of a made for modular project. So those prison cells, one you can see on the hoist there, on the crane there, sorry, is 2 prison cells. They come fully finished, they're painted, the door is on, the security's on, the window is on, the toilet is mounted, the sink is mounted, the bed is mounted to the wall. I don't think they shipped them with the mattress, but they probably could have done. These things just came from the factory that way. And we were able to install 258 prison cells in 12 days. That took 4 months off our schedule, which, although that solution was a slight cost premium over the stick-built version, the 4 months financing cost was essentially what won us the job in the end. What we learned from that one was it also took a bunch of the masonry work off-site, which is extremely time-consuming and it's extremely messy. We also learned that because we could reduce the amount of work that was done at height, our safety record improved significantly. And the other challenge with the prison environment is you have to get everybody through a security check because they're walking in and out through the prison every day. Well, now you've reduced the number of workers that you have to go through that, which means that you impact the efficiency of everybody and you reduce the daily time commitment that takes up. So then the Humber River Hospital, it's another P3 hospital for us in Toronto, $1 billion project. And the real reason we looked at off-site solutions on this project was that we wanted to shorten the schedule for room finishing, but we also wanted to reduce the on-site manpower requirements and associated logistics. At peak, this project's going to run somewhere around 2,000 to 2,200 workers on site there. So our original scope on this one was 400 bathrooms, 500 head walls, and 14 data rooms. So all the data rooms we built in our shop, delivered to site, and the site install was 1/3 of the time required to do it the stick-built version. But more importantly, it gave those head-end rooms to our electrical contractor 3 to 4 months earlier than he would have got them conventionally, which is a huge advantage to him. The bathrooms we put into production into September, and we ended up with a slightly reduced scope because of design changes, but we produced 360 bathrooms in 3 months, out of the factory, out onto site. Head walls were a bit of a lessons learned for us. We had 500 of the same Type 27 head wall. Great, let's build 500 Type 27 head walls, until we started digging in. Type 27A, B, C, there were 38 versions of Type 27. So at that point we said, listen, it doesn't make sense anymore. So we dropped that from the package there. But the other thing with this one, we came at this after the fact and incorporated an off-site solution into it. It's far, far better if you can build it into the plan up front. And another good example of that one was the electrical closets. There were 200 electrical closets spread out through the priority corridors in the hospital. And the general superintendent on the job said, why don't we prefab these? Why don't we modularize them? We said, great idea, until we started looking and realized that every single one had a slight variation. It was a slightly different wall type, slightly different dimension. And then, again, now there's no repetition, it doesn't make sense, or makes less sense. Whereas had we been up front, we would probably have identified, yeah, there's 200 electrical closets. Let's standardize the design for 3, 1 panel, 2 panel, 3 panel. And maybe it's overkill, maybe it's got a 2-hour rated on every single one when it doesn't need it. But now we've got a standard catalog item that can get designed and dropped wherever we need it. Now you get that repetition. Now you can get the production abilities. So for those of you who wanted the picture, there's a picture. With the lid taken off, we took this is what it would look like without the ceiling on. We didn't put a floor on these because of the zero transition. We've since figured out a way that we could have done that. And we wouldn't put the toilet on just because the porcelain is one thing that tends to crack in shipping. Everything else would have gone out that way. So this is us under full production there. There's probably about 72 bathrooms at various stages of progression. And at one point we were pumping out 60 bathrooms a week out of the door to go to site there. We'd get 4 on a truck, we'd shrink wrap them in the shop, load them onto the truck, and once they got to site, we'd hoist them up into place or up onto a landing platform, and we got that down to about a 15-minute cycle to get one off the truck up to the floor and over into place. We couldn't find a landing platform big enough, so we built our own. We believe that's the world's largest construction landing platform. Certainly, people out there who advertise in the largest one, this one's bigger. So, and we got 2 of them. So that's kind of a claim to fame thing there. And then we'd roll them across the floor. We could have came up with a system of skates on casters to be able to, the guys, 2 guys, 3 guys would be able to roll that across the floor, concrete slab, to get it to the final location there. And I talked earlier about using it to coordinate. That was pretty tight getting it under that pipe work and duct work, but that was figured out. I'm not going to say to the millimeter because the construction tolerances weren't that tight, but certainly to the inch to figure out how we would do that. So those are examples of individual multi-trade components. And while it's progress, it only takes us so far. Next step is to start to combine these components together to give us a more complete solution. So it's more like the Ford assembly line, but on site. So I'm going to walk you through what that looks like, and this is what we're calling our second generation MEP racks. So on these jobs, we're now starting to look at incorporating the drywall into the side of it, bringing the bathrooms in to click into the MEP racks. This is a sequence we worked through where we had a series that working down a corridor that in the space of a day, we could have 8 rooms worth of MEP racks in the corridor, the bathrooms, and the interior MEP med gas distribution happening. That's where we've got to start to go parts and pieces that physically snap together on site and go to reduce the amount of infill work that's needed. So there are a lot of benefits. I've mentioned a few of them as we've gone along here. First one is it improves safety. And one of the biggest things, we take all the work from way up here on a ladder and do it down on ground level at workbench height. Now, ergonomically, it's far easier to work, quite apart from the efficiency. So we bring that down. The other thing that we've done is taken the variables out of it. Any site that has an incident, it's almost certainly because of the variables. It was dry this morning, it rained over lunchtime, now the floor slab is slippy, or it's icy out there. The slab was clean this morning, somebody's been out and there's a bunch of cords tripping hazards or variables. They cause all sorts of safety and quality concerns. Factory environment, you can get rid of those variables, which in turn reduces your hazard exposure. It improves your productivity. There's far less wasted time looking for materials, looking for tools, because everything you need is right there at the work cell that you're working on. Even traveling to the workplace, so you go past a high-rise project, how many guys do you see stood waiting for the man hoist every morning? That's a 20-minute, 30-minute, and that could be 2-3 times a day that that's happening. Our industrial group have seen significant improvements in their productivity building here in a module yard and a prefab shop in Edmonton versus building up on site in Fort Mac. And we saw, even when we built those bathrooms, our mechanical trade gave us a credit for the number of hours for doing the same work that they were now doing in the shop on site. But they said, you know what, we already prefab most of our stuff, so we don't think you're going to save any hours. At the end of the day, the number of hours they spent in the shop to the number of hours they spent on site was 55%. And even they were amazed because they suddenly realized that because they were working with other trades, they could do so much more with their prefab. The electrician was over a 60% savings in the man hours required. All 360 bathrooms in 3 months, 1 electrician. At a more countrywide level, or even continent-wide level, productivity is measured in terms of dollars of GDP, dollars per head of GDP. And this is a graph that many of you may have seen. The top line is the growth in GDP per head on every other industry other than construction. And it's more than doubled over the last 50 years. And construction has actually gone down by 25% in that same timeline. So now we are far less productive than we were 50 years ago. When you start to build off-site, you can accelerate your schedule. You can be doing more work in parallel with each other, which means that now instead of delivering the first piece of raw material, you're delivering the finished product, which can be installed far quicker. That install time and the time that you need on site is critical. It also allows you to use your manpower far better rather than going in fits and starts and bursts of activity. It's also going to improve your right first time quality. And I come back to you've removed the variables. If you're building a student residence and maybe you've got 50 bedrooms or bathrooms on a floor, you've probably got 5 or 6 crews framing that. Well, if one of them figures out how to frame it right and the others get it wrong, you've got a whole bunch that you've got to fix. On a production line, you do it wrong the first one, the guy picks it up at the next work cell and said, this is wrong, you fix it at the root. Same guys get into a rhythm, they get used to doing it. That's when you get your better quality. It also reduces your environmental impact. If we have leftover material at the end of the job, it goes back on the rack ready for the next job. It doesn't go in the dumpster like it would on site. We also use that automation, that CNC equipment that I talked about earlier, as nesting software. So instead of getting 2 pieces of drywall out of a sheet, we could maybe get 4 or 5 cut pieces out of that. We're also bringing the work to one location and getting everybody working there, less people, but working more efficiently and effectively. That means less vehicles going to site, less emissions, less waste at the site to work with. It also allows us to flatten out that workforce, do it with a smaller number over an extended period of time, but it also opens up our workforce ability, who we can hire in the shop, who that's open to. Age, gender, disability are far less of an issue in a factory environment. You go into any manufacturing facility, it's probably a 50-50 male-female split. Construction site, it's normally 95-5 is the general straw poll that I've taken over the years here. So a lot of benefits. There are some drawbacks. You've got to have that design finished early. If you're going to really make use of it to accelerate your schedule, you've got to have that finished. And that's really where the model can be a big help with this. Getting that information into one place, coordinated, agreed upon early, that's critical. But once you've done that, very difficult to change it. It's now on a production line environment, and if you want to change something, you're going to press pause or press stop on the line. It gets very expensive very quickly, or you're fixing it on site after, changing it on site afterwards. If you're going to get the most cost effectiveness, you're really talking about doing maximum repetition there. You also have to think about, what am I shipping? How much is that shipping going to cost? How am I going to hoist it? What size can I actually ship? But over and above all of those, I think the biggest challenge that the industry faces and the biggest drawback is people's perception of what modular is. It's kind of become a little bit of a dirty word over the last 50 years, and as an industry, we're trying to change that because it isn't. You're actually getting a very high quality building, and it's delivered, it meets and exceeds the specs that are called for. So we're just trying to overcome people's reluctance to use it there. So how is it going to get greater acceptance? Well, I think we're starting to see that. We're starting to see a much greater utilization by general contractors. We're seeing more interest from consultants in promoting it as a solution. And with that, we're going to be able to demonstrate that value, start to show people where it adds value. And sometimes it's not cost as a value, it's time, or the cost of time. That's where the value, or reduced punch lists and deficiencies at the end. All of those had value, and we can start to demonstrate it. People will start to see that. But it's also going to need open, collaborative communication. It only works when everybody's working together to make it work. If you've got one naysayer, I think I heard it this morning from Brittany, if you've got one naysayer, it starts to fall apart. So everybody's got to work together. And that means the buy-in of all stakeholders. So in my mind, that comes when everybody on the team has a willingness to not accept the status quo. Everybody has to be looking for unconventional solutions to challenges and opportunities. And this may mean stepping away from traditional contracting and design relationships and working in a space that creates the greatest overall shared benefit to the project. Because everyone needs to see the benefits, otherwise why would they participate? So I'm convinced that PMC, or off-site solutions, is the future of the construction industry, and there are a number of things that are either driving or enabling this. Our clients, they continue to push for better quality, shorter schedules, and greater value for their money, and the only way we're going to achieve that is by doing things differently. We're also facing some huge demographic changes in our workplace, and we're going to lose much of the expertise and knowledge and experience through retirement over the coming years. And that's going to really force us to reevaluate how we use the less experienced workforce that we do have and use it as effectively as possible. If we look beyond North America, Europe and Asia are anywhere between 15 and 20 years ahead of North America in terms of their use of prefab and modularization. We're seeing more contractors come from those areas into our marketplace. So when they come, they're going to be bringing this technology and this approach with them. Just an interesting statistic I found out the other week, 45% of all UK government-issued RFPs are modular calls. They are specifically looking for off-site solutions and approaches on their projects. There are also societal pressures on us that are forcing us to reevaluate how we ensure the safety of our workforce, our environmental impact, workforce diversity, and even work-life balance. And all of these are going to necessitate changing our standard approach. And finally, technology, why we're all here today. It's come along leaps and bounds in the last 10 years, and it's continuing to do so at an accelerating pace. We have the opportunity to harness this as an industry and to our benefit. And so BIM is already a major driver in this, but I think it's going to become far more powerful as a communication tool, particularly as we start talking about the Internet of Things. So if we harness all those drivers and enablers and where the technology can take, what could that look like? I just want to run you through a few ideas that we have. What if you could pre-build all your mechanical and electrical rooms as complete units? What if your elevators or stair shafts came as ready-made stackable boxes that got you up the building far faster, reduced or gave you far better flow for your workforce as you went? Doesn't have to be new build construction. These are units that we built in Toronto and shipped to Calgary for retrofit applications in a lab building. Went in extremely quickly. Operating lab building took the install time down from 4 weeks to 4 days by building all of the stuff off-site. Bridges. This is my BIM backup. I use pen and paper because I don't know how to use BIM. But bridges, why not? Why can't we prefabricate them off-site? And I'm going to give kudos to our friends at the back of the room there. They just installed a bridge in Toronto where they actually they built it off-site and slid it in under the expressway one weekend and got it into place. That's starting to look at things differently and approaching the world differently. Elevator machine rooms. This is kind of I didn't want to give all of our secret sources away here, but what if you could land a complete elevator machine room on the top of the building and get your elevators up and running that much faster? All of these are things that we've got to look at. Exterior wall panels. The curtain wall guys figured out 30 years ago that their guys were far more productive and safe, and they got better quality when they took that work off-site and built it in a factory. But why does it have to be limited to a 5 by 15 foot panel? If I can get an 8 foot by 53 foot panel on a truck, that's the size of panel I want to build. And I want to have all the windows in there. I want to have the finish on it. I want to have the insulation, air vapor barrier, everything on it, maybe not the inside drywall, but everything else. If I can get that building weather tight that much faster, our finishes can start that much faster. So, in the 2012 report, FMI predicted that in the upcoming years, modularization and prefabrication will play an increasingly vital role in improving the productivity of the entire construction value chain, on a par with lean construction techniques, alternative project delivery methodologies, and 3 and 4D modeling. I believe it's coming, whether the industry wants it or not. Our take is that it will change the industry. It will change the way the industry looks significantly. We're going to see shorter schedules, greater cost efficiency, better quality, reduced environmental impact, and significantly better safety stats. And these are all benefits that are hard to ignore. But it can only come when we accept and embrace the paradigm shift that PMC creates. BIM is going to play an increasingly important part in achieving this shift. It's starting to gain momentum, but it's nowhere near being used to its full potential. And if we all put our mind fully to it, the opportunities are limitless. Thank you very much, and happy to try and answer any questions.
Hi, Stuart Burdett with Star Pre-Built Homes. We are just transitioning into BIM, introducing BIM to our manufacturing facility. Everything you're saying, we totally agree with, and we're washed in the blood of the Lamb, whatever we want to say in terms of BIM rollout. But how do we pass on these incentives to the workers? Through just working in a warm factory, that's great. Doing a better job, one job at a time, the Kaizen, good work down the line. We're improving ourselves, but do we pass on the financial benefits to the workers?
Yes. Okay, very simply, yes. We are a manufacturing facility. manufacturing labor rates are lower than construction rates. That's a fact of the industry. Our guys figure they actually make more money in the shop even at a lower rate than they do out on site because they don't lose 2 to 3 days per week due to weather, or per month, sorry, due to weather. They also still get overtime. We still have needs to work overtime, but they don't lose that time, that time and that pay. Just as an example, we had a lull over Christmas time, and we were, okay, guys, maybe we should go and ask the guys if they'd mind if we shut the shop down for 2 weeks. And the guys said, oh my God, thank God you let us do that because we haven't had a day off in weeks. They get so used to that site environment where 1, if not 2 days every couple of weeks, and sometimes extended periods, they can't work. It's too cold, it's too wet. Wind is stopping the crane swinging. Any of those things stops them from working in site. A couple of years ago I was saying we never lose a day to weather. And actually last summer I had to retract that. We lost 2 days or 2 afternoons for weather. In Toronto we get this humidex stuff, and so the temperature was 35 and the humidex was well over 40. We just could not keep the shop cool enough, and it was becoming a safety issue. So we got the guys would start at 6 and they'd work till about 11, and then we'd send them home. So yes, weather does impact us when it gets too hot. But other than that, it's a dry environment, and dry is good from an environmental perspective. No mold, no moisture out on site to start to damage your materials on site. So I would say, yes, our guys, they are certainly as well paid as they would be on site because of that differential there in terms of the number of hours, but they also get the benefit of working. One of the things I touched on earlier was that diverse workforce. We've got several guys in our shop who have said they wouldn't still want to be working out on site because they're getting towards the end of their careers, can't climb all the ladders they used to, can't deal with the temperature changes that they used to, can't carry as much as they can now do it in a shop, nice flat slab, no climbing stairs or ladders, weather doesn't change. We get to keep that workforce, we get to keep them engaged, we get to gain their experience and share that experience with the rest of our workforce. So,
Dave McCarricker from the Mitchell Partnership. I'm very familiar with this modular offsite construction concept, and when it works great. But have you ever come across any issues, and I'm talking about union issues, where union labor on site, particularly with the plumbing, would not want to accept pre-manufactured pipe racks that came from a factory where they were not built with a union label?
We're always very careful with that, and we use union labor to do all of our own work. We are a union shop. And we also used the same contractors who were on site doing mechanical, electrical, came and did the work in the plant. So we kept that, because it was even the same crews that worked on it. So we tried to get away from that. But I'm going to get on my soapbox here, and this is pure me. This is not PCL. The union environment is what is stopping this from progressing and gaining traction. If I look at Europe, they have unions that represent the workforce, but that's what they do. They represent the workforce. That whole sector has spread dramatically because it's not being constrained by somebody saying, that's my work and nobody else is allowed to touch it, and you have to do that for me because I'm not allowed to do that. If we can get past that and get to the point where we're working collaboratively together, and it doesn't matter whether that plumber actually picks up a saw and cuts a hole to put his pipe through because he's not worrying about jurisdiction. I think that is, in all honesty, one of the biggest things that's holding this back from growing more. So that's personal soapbox, and I'll get off it now. So. Hey, front.